Hey folks, welcome back to the shop. Frank here. We're continuing to work on the Cub Cadet articulating dump truck tractor, four-wheel drive tractor. Last time we flipped the ring gear on one of the differentials. I did the second one off camera. We also started on drive hub for the engine. So this episode we'll finish the drive hub and fit that up to the engine. Then we'll reassemble the transaxles. I'll do one on camera. I'll do the other one off camera. No sense doing it twice for you. And then at the end we'll test the hydrostatic transmission and differential to make sure it's working as we expect that it will. It actually does run backwards. Don't have any concern about that, but I'll show you how to test these transmissions. So let's get back on it. I'm anxious to get these things back together. All right, here's my setup for broaching the keyway. I've got my air over hydraulic Harbor Freight 20-ton shop press. So up here I've got the 20-ton jack. It's got air connection, and I've got set up with some blocks to raise the sleeve or collar off the supports. So we're going to go ahead and try to press this broach through. All right, the first pass worked fine. We put our little shim in here. I have a rubber mat on the floor, so the broach, landed on the rubber mat when it fell through. Put my face mask back on. Just stacking spacers on here. I've only got small amount left to go here. I wasn't happy with the disc I cut out. I'm going to try a different approach here. This is for the drive hub. All right, taking a slightly different route. I cut this out on the plasma table. Gonna weld that together like that, and then this will be the drive, the other half of the drive hub assembly. So that's the plan for that. Of course, at this point, I've failed to turn the microphone back on. Just cleaning up the little bracket that we cut out on the plasma table, getting ready to weld hub to it. I've got the hub clamped to the bracket. There's a little centering spacer which aligns the hub to the center hole on the bracket. Get another clamp on here. I want to make sure that, when I weld it, it doesn't warp out of alignment. I mean, there's a lot of forgiveness in this type of flex disc joint, so it doesn't have to be super accurate. I'm going to put a couple of tacks on each side here just to hold it temporarily. Always good to get a couple tacks on it right away, opposite side, just to hold it in case it decides to shrink and move. Always a problem with welding stuff. A little bit longer bead on the one side, come around this side, another bead. Dealing with the clamps in the way here, of course. Not a high stress joint. The torque is not that high on this bracket. Just putting another little bead on each side for good measure. Probably totally unnecessary, but what I do. All right, got the two set screw holes. Using two different cameras here. The camera on the mill had its microphone. This other camera I have the remote mics that I failed to turn on. So I'm just assembling this flex disc joint here with the new hub, adding the set screws. So these flex joints are pretty forgiving.
They do allow for a misalignment between two connection points. The longer shaft extending out to the left here will be connected to the transmission. Here's the hub going on the 1-inch crankshaft, output of the crankshaft. And we'll move that fan. That fan really doesn't belong there, left over from the previous connection. So there's keyways on the shaft. They were messed up a little bit by the previous owner. I did pull this basket pulley assembly off, which took considerable effort, actually about an hour, applying heat, working on the set screws. Pried it off by putting a crowbar behind it, 3-foot, 4-foot crowbar behind it, and push it off. You want to do that. You want to push toward the center of the hub, not around the edges, because it is just a sheet metal pulley. You can drill holes in the face of it, tap them, and then screw a couple of bolts in to push it off the shaft if you have to. Can't use a pulley on it because it's too fragile. I've got it back on. We'll put the key back in there. We'll have two separate short keys, one for the back for that basket and one for the drive hub. It is a 50-year-old tractor, so it's no telling what previous owners do or have done over time. The back half of that keyway is pretty, but there's not a whole lot of torque on this basket assembly. Basically, there's no PTO that's being driven by that keyway, so it's not going to be a problem. Key is not, a really good fit.
All right, that's a snug fit on there, which is not a bad thing. All right, so this will be the coupling between the drive shaft and the input. So let's go ahead and drill a few holes. Let's go ahead and drill a few holes. that. So we'll drill a 1/4 inch hole here for a roll pin here. We'll drill 2 holes. While we have it set up, let's do them both. Alright, finding the center between these 2 faces will also give us the center of the sleeve. 3.18. And these locations are not particularly critical. Just need to get 1/4 inch holes all the way through. Alright, so there's our coupling. You know, the only important thing really here is that the hole be through on a diameter that is centered, so that you'll be able to drive a pin through this way as well as this way. The problem is sometimes people will put a shaft in here and drill a hole through it, and it won't be on center, and then it will only fit one way. Rotate it and it won't fit because the hole's off center. So that's a helpful thing to have it on center, clearly. Yeah, that's much better. Okay. When time comes, we'll put a roll pin in there. All right, let's see about doing a test fit here. our all right, that's pretty close to the right position. Okay. All right, and then the second key would be for our drive hub. This is a little tighter fit because, yeah, there's a burr on here from where they ground off the old key. Let me get a file. This is actually a square file. First time I'd seen one of these, thought it might have a purpose. It's still a little too tight. So this is a single cut file. And I'm trying to I'd rather work on getting the key to fit the keyway rather than messing with the keyway, because the keyway is much more difficult to fix if I mess up. I can always make a new key. So all right, that's getting much closer. Get a drift. I'm just using this to seat the key. That's nice tight fit there. And then see if we can get our drive hub on. Oh yeah. Okay, that's going to be a nice snug fit. All right. All the way on there, looks like. All right, that looks like a good fit. Do I have a couple puppies? How my boys doing, huh? How you guys doing? I told you a couple weeks ago that all it takes is me to sit in this, move this little stool around, the boys come looking for some pets. All right, sit, sit, sit. That's a good boy. That's a good boy. Yeah, you're such a good boy. Give me that paw. You want some pets over here, Butchie? Huh? Come here. Come here. Come here. Yeah, you're such a good boy. I got these guys locked up in here with me this evening because they have a tendency to bark a lot. I don't know why. Make sure these collars fit properly. Yeah. You're such a good boy. Yeah. You're such a good boy. Got some gaskets today. Two longer bolts go up here. They eventually have the frame going through here. They say this one goes all the way through, so it needs sealant on the thread. Actually, that one doesn't penetrate the case, so really only that one does. All right, that worked. Just basically using this as a gasket sealer. Because the cover plate that goes on here is thin, I mean it's like 12 gauge, 11 gauge or less. Doesn't make as sure a seal as for example these cast iron axle housings make. So it's almost always a good idea to put thin layer of sealant on the gaskets. So normal operation, this is your fill and level hole. But since we've got the top off, we'll just fill it here and use that as our level marker. All right. Start to come out of the fill hole. Close that off. So there's no pressure on this gasket. This cover is just to basically keep the dirt out. So this is the test. We're going to drive the hydrostat here with this shaft and a drill. That's working. It's driving this one. Let's see. So if we stop this one, the right one drives. All right, so it looks like it's working fine. Put it in neutral, and then go the other direction. So I think we're good to go. Now it's important that you drive this clockwise from this side. Be counterclockwise from the other side. But that's important. It won't work if you run it in the wrong direction. The charge pump only operates in one direction. The charge pump provides fluid to the hydrostatic drive. All right, I'll try to explain briefly how hydrostatic transmission works. So the top portion is basically a hydraulic pump. There's a round piston block with 9 little pistons. They're, the size of your little finger. And when you drive this, the swash plate in here pivots back and forth and changes the amount and direction of the fluid flow. The fluid flows down to the bottom half. There's an identical piston block with 9 little pistons, and the ends of the pistons have slipper feet on them, little brass, they're called slippers, that ride on the swash plate. At the bottom, there's a fixed angled swash plate. The direction flow of the fluid under high pressure goes down to the motor section, and it causes the output shaft to rotate based on the pressure, due to the pressure of the slippers and pistons against that angled plate. And that piston block is keyed to the output shaft, so the pressure of the piston slippers against that angled swash plate, which is fixed, causes that piston block to rotate and output. It's keyed to the output shaft. So this is the inside of a hydrostatic transmission. This is the piston block, one of them. Let's see, this is the pump section, and here's the swash plate in here, and it pivots back and forth. The pivot shafts are gone, but it pivots back and forth like this. Changes the motion of the slippers, the pistons and slippers in this block, and then the fluid flows into the other block. Here's a plate. The plate's supposed to go on the top here, like that, down there. So there's a fixed swash plate there. This piston block is keyed to the output shaft, and so when it rotates, this output shaft rotates, drives a reduction gear. So it creates the ability, infinitely variable and change in direction based on the swash plate motion. I'll put some pictures up of the slipper feet. I thought I had some, but I don't see any in my stash right now. All right, that's it for this episode. We got the drive hub completed and fitted up to the engine, dealt with the messed up keyway, got some new keys in there. I think that's going to work fine. Got the transmission, the first transmission, which is actually the second one, because the first one we took apart and worked on is still sitting on the floor. I haven't put it back together yet. But we got the ring gear flipped in both the transaxles, got this totally back together and tested it. It works exactly as we anticipated. So that's the good news. Between now and next week, I'll work on the second transmission. I'm not going to record that. You don't need to see it twice. But next episode, we'll come back and we'll start fitting up the other transmission, which is the one intended for sitting behind the engine. We'll get it fitted up to the engine, try to complete that installation, see how far we can get. So again, if you're interested in this stuff, a thumbs up would be greatly appreciated. If you haven't subscribed, please consider doing that. And ring the bell so you get notified of upcoming episodes. Share with your friends. Leave me a comment. YouTube loves comments. I like them too. I read them all, and I respond to every comment that asks a question. For example, I try to answer every question. So I appreciate the comments. So thanks for watching. We'll see you next week.